Viewers, experimentation is one of the methods a teacher is supposed to use while teaching, implementing a competence-based curriculum. So without wasting time, I've come up with a question where we are supposed to use experimentation as we implement a competence-based curriculum. You may ask yourself, why experimentation? It is child-centered. It makes the lesson interactive, participatory. It stimulates critical thinking, effective communication, problem solving, and other skills which are reflected in a competence-based curriculum. So if you can check in my background on the chart, you can see that question that is there, the question that I'm going to read. So you are provided with the following items: a conducting wire, a dry cell, and a bulb. Question A. Name one other item that is missing on the list above. By the way, teachers at P7, we are supposed to teach components of a simple electric circuit. Things like ammeter, voltmeter, resistor, we are not supposed to teach them. So the answers are already reflected on the chart for question A. In other words, what are the expected responses? Part B, describe the steps that you can take to arrange a simple electric circuit using the items above. And that's where you are supposed to make your lesson more interactive, hands-on. So what is the first step? Connect one end of the wire to the positive terminal of the dry cell. So this is the wire. I've connected it to the positive terminal of the dry cell. And I've used so many dry cells. Why? Because the bulb I am using requires, it is a high voltage dry cell, in other words. But in the real sense, we are supposed to use one dry cell. So the first step, as you can see on the chart, connect the one end of the wire to the positive terminal of the dry cell, like I have done. Step 2, connect the other end of the wire to the negative terminal of the dry cell, like the way I have done it. Then the third step, place the bulb in contact with the positive terminal of the dry cell, like this. You can as well add on this statement. The circuit will be complete, as you can see, and produce light. And if it is a diagram, the candidates are supposed to put some signals here on the bulb to show that the bulb is producing light or the circuit is complete. Something I want to correct here: when we are teaching electric circuit in P7, we are supposed to teach complete circuit and incomplete circuit. A complete circuit is like the one you are seeing right now. A complete circuit, in other words, a complete circuit is that circuit that produces light. An incomplete circuit is like, for example, this one. It is a circuit that does not produce light. Meaning that with a complete circuit, you are supposed to arrange all the components very well, so as the bulb produces light. An incomplete circuit is that one whose components are poorly arranged, and therefore the bulb will not produce light. What could be some of the points that you should emphasize in your learners so as to enable them know how to answer questions of this nature? In other words, the mistakes they normally commit: one, poor organization of work. You find they write their answers as if they are writing a composition. In other words, you fail to get where to place a mark. Instead of outlining their answers, and they should be short and precise. They should not write long statements. They can use Roman numerals, they can use outlines or bullets, or they can use ABC. Another thing, they are supposed to arrange their answers in the correct answer sequentially. How these activities follow each other, not in a jumbled manner. Then the last one, they are supposed to double check their answers. But the best way you can guide them, they can first write their answers in pencil. Then after double checking their answers, cross-checking their answers, they can use a pen. That is what they are supposed to do. Subscribe and wait for me in another video that is coming. Thank you.